everyone, I'm Ian and I'm at the Fleet Science Center, and today we're going to be talking about fans, and specifically we're going to be looking at the electric motors inside of them. The first thing we're going to take a look at is a hairdryer, and so this is a relatively simple device. It has a couple options for speed, so high, low, off. So there's just a couple screws on the handle here. All right, so we've taken the back housing off, and you can see here, here's the fan. So we can pull that off. It's just connected to this tube. Let's take these wires, all right, and we can set the housing to the side. So you can see here are the controls for the switches that we saw in the front. So this is the high-low. This I think is going to be the heat, or whether you want heat or not. There's that button on the front here that did that. And so now let's pull apart. Looks like there's just a couple tabs to remove the fan from this housing. And so what we see here, these are the heating elements. And so the way that the hairdryer works is it sends electricity through these, and these wires are made of a special material, or a certain material that has resistance. And so when a material has resistance and electricity is flowing through it, it'll create heat. So now let's see if pull the motor off. And so now we have this fan. So let's separate these two elements now. So we're going to separate the heating away from the actual fan, the motor itself. We can see that the fan is powered just by a little electric motor. Let me see if I can pry it off from its housing. All right, so we got the motor and the fan separated from that housing. We had to actually just cut it apart. But what you can see here is, you have your fan, and then the motor is just connected right behind it. I don't know if you can see from this angle, but there's some copper wiring on the inside there. And when the fan turns, you can possibly see that copper wire turn, and it does that because when electricity comes through the motor, it creates a magnetic field, and in particular, it creates an alternating magnetic field. And when that happens, the motor is designed specifically to rotate with that alternating field. And so that's what produces the air that gets pushed out of the hairdryer. One thing to note is that the blades on this are at a very sharp angle. So if you've seen like a fan, like a ceiling fan, or maybe a window fan, something like that, like we'll take a look at later, those blades tend to have a much shallower curve or a shallower angle on them, whereas these are very sharp angles. And what that does is that causes it to move a lot of air very quickly. All right, so there's our fan from the hairdryer. This is the heating element, which heats up again using electricity. And now let's go ahead and take a look at another fan. All right, so here we have a window fan. You can see it's actually a dual fan, so it has two blades. There is actually a bit of electronics in here. So if we turn it over to the front, you can see this is where the power button is. It has speed selection. It actually also has a temperature sensor, and then a display telling you what that temperature is. And so that's what this control board here is. There's also a power board, which converts the incoming electricity that would have come from this wire. You plug it right into the wall. Looks like there's a couple transformers, some capacitors, to both change it from the alternating current that comes from your wall plug to direct current or DC current that the electronics on this board need. So that would be one of the jobs of this power board, as well as then providing power to the motors that are underneath these fans. So let's first go ahead and take off the fans. So these are just held on with a nut, so we can take that off. All right, so now I'm going to pull the blades of the fan off. So there's one, and there's the second one there. And so now you can definitely see here the electric motor. So you can see those copper coils. It's going to be the same thing inside of this one, but you can see much more readily on this larger motor here. Let's actually see if we can take those out so that you can see the actual mechanism that turns when power is applied and the motor spins. All right, so with those screws gone, we should be able to pull this out. And there we are. So I don't think you can still yet see the drive inside, but you can see the copper coils, how they go all around. There's this metal interior, and when the electricity flows through those coils and it's wrapped around that metal, it creates that magnetic field that I was talking about. And that causes the motor to spin. And so let me see if I can get this apart a bit further and we can see more what's inside. All right, so I've taken that motor apart from the fan. I've removed it here, but now you can definitely see the copper coils that sort of provide or make that magnetic field. And then inside here you have the drive shaft essentially, and this is what spins. And so when the motor is inside here, a current is applied, creates a magnetic field, and it's an alternating magnetic field again. And so what happens is it causes this middle part to rotate. So it's actually this big, looks kind of purple, but I think that's just because it has some grease on it. But it's essentially a big sort of magnetic piece of iron or something along those lines that's affected by the magnetic field, and it turns. And so what's kind of neat about this, so we have sort of this large motor here, or relatively large motor there, but it works on the exact same principles as the electric motor that we saw with the hairdryer. So we can't take this apart, but again, this fan blade is connected to this drive shaft, which has a bit of magnetic material in there. The copper coils in there gets the power, the electricity, just like this one does. Again, bigger motor, bit more power, and it rotates. And it's the same technology that's used in pretty much anything that has some sort of rotational movement to it. So from your microwave at home, it might have the plate that spins. Any kind of fan you have, if you have an electric drill, it'll rotate like that. Even an electric toothbrush essentially uses a motor like this. And if you remember from a previous episode where we looked at the video game controllers, how they had the flyweights on it that caused sort of the vibration, your electric toothbrush is kind of going to do a similar thing there, and that's how it gets that vibration motion in the toothbrush. And so with that, I hope you enjoyed this episode. I look forward to talking to you next time.